Good morning. How are you? Hope you are all in the pink of health. I am Atun Rai and you are watching Bond Making and Bond Breaking channel. On my previous video, I have discussed about alcohol, their properties, their preparation, their chemical reactions, as well as the phenols, their properties, their preparation, their chemical reactions also. Now I am going to discuss with about ether. Do you know that what is ether? Ether is that R bond O bond R. Two bulky group join with oxygen. This is called ether. It may be similar, that is symmetrical ether. If this is similar, if this is not similar, this is called unsymmetrical ether. If this is ethyl and this is methyl group, so this is unsymmetrical ether. We know it. Okay. So nextly, I am going to the method of preparation. So I am going to discuss to you preparation of. So I am going to discuss to you preparation of ether. Okay. Now preparation of ether means if you take CH3, CH2OH and you use concentrated H2SO4, what do you get? You get that OH you can write in this way, this is OH, okay, you can write in this way, and CH3, that is CH3, you can write in this way. So H2O water molecules is removed from here, so the product is CH2 double bond CH2, but the heat which is required, that is 443 Kelvin. Okay, with 443 Kelvin, if you use concentrated H2SO4 with this compound, with this ethanol, you get alkene group. But if you use this CH3 ethanol, CH3CH2OH, and react with this concentrated H2SO4, but the heat is not that, but the heat is 413 Kelvin. With the change in this temperature, you get the group of ether, that is H3CH-OH is removed from here. Okay, so you get in this way, you take 2 moles ethanol, OH, as well as you get this is OH, CH2CH3, CH2CH3. Okay, so water molecule is removed from here. Okay, so as water molecule is removed from here, you take this CH3 CH2O CH2 CH3. So CH3 CH2O. Okay, very easy. CH2 CH3 CH2 CH3, or smartly you can write C2H5O C2H5, ethoxyethane. As we know that the general formula to write this name is alkoxyalkane. So this is ethoxy. So ethoxyethane, alkane, ethane, ethoxyethane, ethoxyethane. So alkoxyalkane. So this is one method to prepare the ether. Next is Williamson synthesis. Okay. What I say? Williamson synthesis. Now, if you used Rx with the presence of NaOR, okay, sodium alkoxide. If you react with this, you get ether, ROR. This is Williamson synthesis. Okay. Now you take CH3OA, and you react with CH3Br. You write this compound, and what do you get? What do you get? You get this NaBr is removed from here. So the product is CH3 whole 3C, CH3 whole 3C, and this is OCH3. OCH3 I can write it this way also. OCH3. So this product is called Williamson synthesis. Okay. Next, this is also a preparation to prepare phenol, to prepare ether. And next, very easy. Next, preparation for phenol. Phenol to ether. This is named anisole. Phenol to anisole. Okay. You take this. This is phenol. As you know it is phenol. And when it reacts with OH minus with the presence of Na plus. So Na plus OH minus NaOH, you get ONA. So you get ONA, where O plus and Na minus. Then you react with CH3Br. CH3Br, and for this reason NaBr is removed from here, and the product is OCH3. This is R and this is pH, so you can write in this way CH3OPH. So this is also a group of ether. This is also a group of ether. So you can use this method also, phenol to prepare anisole. Okay, this is also ether. This is phenol and it is anisole. Very easy method. So you can use this, you can use Williamson synthesis, you can use the first one to prepare ether. Okay. Then there is also two process. Here. The processor, if you used first one 2ROH and you react with Al2O3, then you react with Al2O3, what do you get? If you use 270 degrees centigrade and 280 degrees centigrade, if you use it, you get ROH plus OHR. Oh, that's OHR. And if you remove this group, so the product is ROR. Okay. Just in this way, if you use CH3OH and you react with this Al2O3, okay, and this heat also, so the product is CH3OH, 2 mole methanol, 1 mole I can write in this way and another mole I can write in this way to understand what is removed from here. So water molecule is removed from here, so the product is CH3O CH3, that is ether. So the product is CH3O CH3. This is the preparation of ether. Okay. Now you can write, you can use OMDM process of oxymercuration demercuration. This process also you can write. What is the oxymercuration demercuration? CH3 CH double bond CH2. If you use OMDM, right, oxymercuration demercuration, and you use H2O, H2 gives you H plus and OH minus. we see that the product is CH3, CHOH and CH2 and 8 also. This H plus goes to the maximum number of hydrogen on this double bond. What I say, this is the carbon, then this is carbon. This is carbon number 1 and this is carbon number 2. The number of hydrogen here, number of hydrogen 2, and the number of hydrogen here, number of hydrogen 1. So we know that the less number of hydrogen, what I say, less number of hydrogen, but the number of hydrogen is less, you use the negative one. So what is the negative one? That is OH. So as the number of hydrogen is less compared than others, so you use the negative. So the negative is OH and you put this OH to this CH. Where the number of hydrogen is more, the CH number of hydrogen is more, you add the positive. So you add this positive terminal or the positive charge. That is it. But if you use CH3 bond, CH double bond, CH2 with the help of this reaction OMDM, but you do not use this water, you used HOR or ROH. Okay, ROH gives you ROH and ROH gives you R plus as well as OH minus. Sorry, this gives you H plus and RO minus. So negative is going here due to the number of hydrogens is less compared than this. So negative charge is coming here, and here the positive charge also, as the double bond is broken. So if the negative is coming here, so we get the compound CH3C. This is OR, so CHOR, as we know that this is OR, and CH2 it gets positive terminal, so CH3. So the product is CH3, but we get the ether also. This is R, this is R, this is O, this is R. So this is ROR compound. That means it is ether compound. So those are the similar things that with the help of that process you can prepare ether. With the process of OMDM, oxymercuration, demercuration, you can prepare this. With the help of Williamson synthesis, you can prepare ether. With the help of phenol to prepare aspirin, aspirin also a group of ether. So you can use this method. You can reduce the temperature. If you use concentrated H2SO4, you can use 413 Kelvin temperature and you can prepare the ether. It is the first method that I have written in this board, on this board. Okay, so these are the preparation. Now there are some physical properties that I am going to discuss with you. What I am going to discuss with you, this is the physical properties. So I am going to discuss with you physical properties. Okay. So firstly, ether itself, what is it? Ether itself, a very good solvent. As we know that the water is a very good solvent, and ether also itself a very good solvent. So this is the first and the very vital phenomena of ether. And ethers are insoluble or less soluble. Ethers are less soluble in water. This is also. Third one, with the increasing of molar mass. It is a general phenomenon. So all the elements with the increasing of molar mass, the boiling point is also increased. Okay, with increasing of molar mass, boiling point is also increased. So this is a directly proportional reaction. Okay. Okay. Fourth one, ethers are lighter than water. What I say? Ethers are lighter than water. So those are the general physical properties. One is very important. It is a very good solvent itself, and it is less soluble in water. This is very important. And with the increasing of molar mass, the boiling point is also. And ethers are comparatively lighter than water. Lighter than water. Okay. So these are the four properties or the physical properties of ether. Okay. Let's go with their chemical reaction of ether. What is a chemical reactions of ether? Okay. Next, you take ROR, chemical reaction. Okay, first one, ROR. You take ROR with the help of HX. Okay, that's fine. You use heat. Heat means high temperature. You use this HX, excess. I say it EX. That is excess. That means excess. Then you use a high temperature, and you get the product, that is, one is ROH and another is RX. Okay. Now if you use ROH but you do not use this HX excess, you use this HX only 2 moles with the temperature, with the presence of temperature, you get 2 RX but you do not get alcohol and water. These are the two chemical reactions of ethers. If you use high temperature with excess HX, you get alcohol as well as the haloalkane. But if you use limited HX, you get RX, that is haloalkane, but you do not get alcohol, you get water. Okay. If you use excess HX with the help of high temperature, you get OH, RX. If you use limited HX with the presence of temperature, you get RX and you get H2O. You do not get alcohol. If you use limited HX, you do not get alcohol, you get water. If you use excess HX, you get alcohol. Now the second and the order of this reaction, the bond length. Where is the bond length is high, this reaction is very faster. So as we know that the HBr and HCl, if we compare this Cl, Br and I with the down the group, okay, when we coming the periodic table down the group, the distance of radius are increasing. As the distance of the radius are increasing, the size is increasing. So as the size is increasing, the bond length is increasing. As the bond length is increasing, the reaction rate increases. So as the bond length between hydrogen and iodine is high, so this reaction is suitable with this compound very much. Okay. Now next chemical reaction. Now you take next chemical reaction, that is, if you use this also, it is also a group of ether. It is also a group of ether, that is OCH3. This is also a group of ether, and you use this HX here. Can you use? Okay. So you get OCH3 and CH3, oh, as lone pair is given, so oxygen shows positive charge. Okay, then you used I minus, then you use I minus. What do you get? You get that H plus and H minus, you get that phenol is prepared here. Okay, if you use HI, then no reaction is occurred. Okay. You use here CH3X, so that's why you get CH3, and from here you used HI, that is H plus and I minus, then you get HX. Okay. So the next reaction is electrophilic substitution reaction. What I say? Electrophilic substitution reaction. This is very, very simple. As you take anisole, OCH3, and the process is bromination, and as well as you know that you get, this is very, very easy. There is no perceptible things. One is on ortho position and another is para position. One is ortho position, one is okay, and you use an acid, that is ethanoic acid. Right? What is the major product? This is the major product, because this is symmetrical. The repulsion force is less. It is depending on repulsion force. Okay. So the next one is, if the process is nitration. If the process is nitration with the dilute HNO3 and H2SO4, you get NO2. As you get NO2, OCH3 NO2 plus OCH3 NO2. Okay, those are very similar with halvalkane, with the previous reaction. So you should not take any pressure. You can use Friedel-Crafts reaction also. LCl3 takes it, LCl4 and CH3 plus here. So you can get OCH3 as well as, so on the ortho position you take this electrophile CH3, on the para position CH. Friedel-Crafts alkylation. Okay, you can use Friedel-Crafts acylation also. If you want to use Friedel-Crafts acylation, then take LCl3 with the presence of CH3COCl and AlCl4. This is LCl3 and LCl4, so OCOCH3 on the ortho and para position. Ortho position COCH3 as well as the para position, you get COCH3. So this is halogenation or bromination, this is nitration, this is Friedel-Crafts alkylation and Friedel-Crafts acylation. Those are very, very similar, and I am Really said. It is very, very easy. Okay. Now I am going to phase rearrangement reaction. Phase rearrangement reaction. Okay. This is phenol. You use it NaOH and pyridine. NaOH and pyridine. If you use NaOH and pyridine, you get this water molecule is removed from here, so you get ON. This is short trick. As I said that it is not mechanism, it is not correct process, but this is the general short tricks. ON. But then you can use acyl chloride, that is CH3COCl. Okay. If you use it, you get COOCl. That is COCl. This is COCl and this one. Okay. Then you acidify it. So the product is OH and COCl. So COCl, that is not COCl, that is COCH3. Then you get COCH3 on this position. Not only this, but also. So rearrangement is occur here. So this reaction is called phase rearrangement. Very easy. You take phenol with the help of NaOH. You remove this water molecule. So Na is here. So ONA, sodium phenoxide ion, sodium phenoxide. Okay. Then you take acyl chloride or CaCl. Then you get this product where the acidification is occurred here. Then the rearrangement is also occurred. So COCH3 on the ortho position and COCH3 on the para position. Okay. Next one is Claisen reaction. Claisen reaction. If you take this phenol and you take this one also, okay, take this one also. You can write it in this way or you can write it in the terms. You can write this also. What do you see that if you take this Cl, okay, I give you one also NaOH, so you get here O minus. As water molecule is removed from here, so you get O minus. Then you use this one. Then you use this one. Okay. So what do you get? You get this product. O minus is ready to give this product and this also ready to create minus. When negative charge is coming to create bond, this loosely bonded pi bond is broken. So you get this negative terminal. Okay, you get this also. When you get this, you can write it in this way. Okay, this one you can write in this way. This one you can write it this way, and here the okay. As here the H1 also, if you take this H, the bond of this is broken. So you get O minus here. and then acidified it. If you acidified it, this is OH and you get this. Very easy process. Okay. Now I am going to discuss with you the preparation of or formation of aspirin. What I say? Formation of aspirin is very important. This is the formation of aspirin. Okay. You just take this phenol as well as, okay, then you react with ONA, that is NaOH. It gives OH minus, so the product is ONA. It is very simple. OH, so this product is ONA. Then you react with CO2 and with the acid H plus. So what you get? You get OH and this is COOH, salicylic acid. Okay. Then you used NaOH. ONA is occurred here, so O minus is occurred here. O minus and there are COH. Then you used CH3COCl. Okay. What do you get? You get this is COH and you take this CO double bond O CH3. Aspirin. COCH3 and this also. This is aspirin. This is phenol to aspirin. Phenol. This is the formation of aspirin. Firstly, we take phenol, it reacts with NaOH, you get ONA. Then you react with CO2, you get COOH. And ONA, when you acidified ONA, you get always phenol, OH. And OH, when you react with NaOH, this O gets minus, O minus. And you react with this acyl chloride, you get COCH3 on this position. So you get COCH3. This is aspirin. Okay. Now there is a identification reaction. Now there is a identification reaction. This is Victor-Meyer reaction. If you take 1 degree alcohol and you want to identify it, you get with this reaction red color by the Victor-Meyer process. If you take 2 degree alcohol, you get blue color. If you take 3 degree alcohol, you get yellow. You get colorless. Colorless. Okay. If you take 1 degree alcohol, you get red color. If you take 2 degree alcohol, blue color. If you take 3 degree alcohol, colorless. So I take one process, that is RCH2OH. Okay, then you react this P and I2. It gives you RCH2I. Okay, then it reacts with AgNO2. So AgI is removed from here, so the product is RCH2NO2. Then you react with HNO2 and you get RC. One is double bond NOH, another is single bond NO2. Then you react with NaOH. OH and H is removed from here, so ONA is occurred here. So R bond C double bond N, OH and H is removed from here, so the product is NONA. NO, Na, and here NO2. This color is red. Why this color is red? Because this is 1 degree alcohol. So prove it. This is 1 degree alcohol. Now, if you take 2 degree alcohol, that is R2. Now, if you take 2 degree alcohol, R2 and OH, it's react with red P, and I2 you get R2CHI, and you react with HNO2. Okay, you get RCH2NO2, RCH2NO2, and then you react with HNO2, you get R2CH, there is not CH, this is CH, so CH is over here, so you get R2NO2, and on the other hand NO in double bond O. If you react with NaOH, you get blue color. Firstly, you used red P and I2, you get this. Okay, then react with HNO2, then react with HNO2 also. After that, you used NaOH and you get the blue form. If it is 1 degree alcohol, you get red form. But if you get 3 degree alcohol, R3CHOH, it cannot be processed. Okay, so 3 degree alcohol colors. This is the Victor-Meyer process. So the next one is MPV reduction. So you get this ketone also, RCOR, this is ketone group, and you take CH3COH, this is 2 degree alcohol, CH3, and you want to react with the help of MPV reaction. For MPV reaction, you can use CH3, you can use CH3CHO, and as well as if you use aluminum, the valency of aluminum 3, so 3 is here. So this is MPV reaction, and you get the product is MPV reaction, you get product is RCOHR, and finally you get it's change itself, so CH3 C double bond O CH3. Okay, ketone, where is ketone? It alcohol is here. Where is alcohol? Ketone is here. So interconversation. There is a mechanism, but we go on simple way. What? Where is the ketone? We take alcohol. Where is the alcohol? We take ketone by the MPV reaction. Okay, this is ketone. This is CO, it converted with COH, and where COH, it converted. This is a simple process. Okay. Now you can get iodoform test. What is the iodoform test? Iodoform test. What do you take? You take this way, RCHOH. This is very, very important, and CH3. Okay, and you want to react with I2 and NaOH. I2 and NaOH. Okay, solution. Then you get CHI3. This color is yellow, and it gives you a precipitate that is yellow precipitate. So it is called iodoform test. Okay, now you can use oxidation. Phenol, if you oxidize it with the help of oxidizing agent, that may be K2SO4 and HCl, dilute HCl, the oxidation is occurred. What do you get? You get that oxidizing method OH and OH, quinol. Okay, very important. This is quinol. Very important. Oxidation reaction. Very important. Okay. There is another Lederer-Manasse reaction. What do you know about Lederer-Manasse reaction? You take phenol, and you want to react with formaldehyde, HCHO and NaOH. You can use dilute HCl. So phenol is react with formaldehyde, NaOH and HCl. If you react through these substances, you get this is OH and CH2OH on the para position as well as on the para position. You must remember it, OH and as well as in the para position CH2OH. This is very important reaction, Lederer-Manasse reaction, and this is oxidation reaction. If you oxidize phenol, you get quinol. Okay, and it gives you on the oxo position CH2OH on as well as on the para position CH2OH. If you use formaldehyde, phenol when react with formaldehyde, you get CH2OH. Okay. There are more reactions. One is if you react with a hydrogen, the phenol, this is phenol, and you want to react with this H2 and this is the reduction process. Okay, nickel powder and 160 nickel powder and 160 degrees centigrade. What do you get? This, the pi bond is broken, so you get the cyclo product. Okay, you can 1 2 3 4 5 6, so you can eat cyclohexanol or cyclohexanol. Okay, this is the reduction process. You can use Birch reaction. Birch reaction means if you use this one and you want to use Na and liquid ammonia, you get the product. I write only the product, final product, that is OH. Sorry, this is, so these are the final product. This is Birch reaction. This is also the reduction process. Okay, so those are the simple chemical reactions of ethers. So I have completed my reactions of my preparation of ether, and the second one the physical properties of ether, and the third one the chemical reactions as well as the chemical properties of ether. So this is the chapter that I am going to discuss with you, and I discussed it. On my next video I am going to discuss with some important question, and I take another video from the important name reaction. Okay, so thank you, have a nice day, take care of your health, and always keep studying because it is really needful, and a book are the best friend, always remember it. Okay, so पढ़ते रहो, ख्याल रखो खुद की सेहत का. Okay, thank you very much.